this walk-in kaleidoscope, I can see myself. Sunlight is bouncing off my body and then reflecting off these mirrors before reaching my eyes. With all of these mirrors, I can see angles that I wouldn't be able to see in the bathroom mirror at home. I can even see the back of my own head, but sometimes our brains can be fooled by the light entering our eyes. When I spin either of these discs, they're optical illusions. If I look at this illusion for long enough, it can cause things to appear to shrink. This is referred to as the shrinking head illusion. This illusion, on the other hand, confuses our brain in a different way. We know that it's a flat disc, but when we spin it, the light and dark can cause the patterns to appear as a 3D shape.
Light is the smallest quantity of energy that can be transported, a photon, an elementary particle without a real size that can't be split, only created or destroyed. Light also has a wave-particle duality, being kind of a particle and a wave at the same time, although this is a lie. Also, when we say light, we actually mean visible light, which is a tiny part of the electromagnetic spectrum, energy in form of electromagnetic radiation.
Why is there so much light on Earth, but almost none once you leave our planet? You might think it's light during the day and dark at night, because the Earth spins on its axis and the Sun illuminates either hemisphere. Well, that's part of the reason, but it's more complicated than that. I mean, our star shines on the Moon too, but the sky above it is always black. It comes down to the unique atmosphere surrounding our Earth. It's full of dust, dirt, gases, and water droplets, which all act like tiny mirrors and reflect the sunlight. When sunlight bumps into these small particles, it diffuses and creates different colors. That's why we see a blue sky and all those spectacular shades during sunrise and sunset.
The angle of incidence of light is greater than the critical angle of water. So instead of refracting, all the colors get reflected back. And now the 7 colors again try to lead the raindrop. This time the angle of incidence is lesser than the critical angle. So there is refraction of light. And that's how we see the 7 beautiful colors of the rainbow.